Welcome to Troutwood Live. I'm Gene Natali with Troutwood. Every company and every person has a story. Each week we host a guest from a company in the S&P 500. We talk about the company, our guest's career, and their personal story. Today's guest lives in Chicago, works for Wabtec Corporation. He's going to be discussing a topic we have not yet covered, decarbonizing global transport. Philip Moslener, Corporate Vice President of Wabtec, welcome to Troutwood Live.
Great. Thanks for having me.
Philip, we appreciate you. We appreciate your time. And my first question to you is unpacking the topic we selected. In your words, help our audience understand what we're going to be talking about today.
Yeah, we'll be talking about, so decarbonization is about reducing greenhouse gases for our planet, and how can we as a company, as engineers, do that, and what are the levers we have. And in my team, we do that, and we do basically play with. I say play because we play with technologies that help us bring these efforts to life. We have decarbonization. We play with AI. We play with additive manufacturing. We play with cloud platforms. But basically, bringing those technologies into real-world products.
Well, and I'll tease our students with a model train in terms of some of where we'll be going with our conversation. So we're going to briefly hop over to the fact sheet on Wabtec to give our audience a visual of the company. And I'm going to fly into Wabtec's Pittsburgh headquarters. A fun fact to read for the audience: more than 20% of the world's freight is moved by a Wabtec locomotive, and more than 30% of all products transported through North American shipping ports are tracked by Wabtec software. Just a really, really neat company. Philip, I'm excited. We have a really great video to share. Before we share, just be curious, a very brief background on yourself before we dive into the formal presentation.
Sure. So I'm an engineer by trade, and I've been in the railway business for over 25 years. I spent first 20 years, if you will, at Bombardier Transportation, which is a global manufacturer of transit passenger trains and equipment, and then moved to General Electric 5 years ago, which became Wabtec, and we'll see that here shortly. But basically, just passionate about the railway industry and how we actually, create products, real-life products that can help our customers.
Philip, can I ask if you are also a model train collector?
Not a collector. I had a collection at one point in time, but I had to leave that behind.
The hobby is not as prevalent as it once was.
Exactly. Yes, it takes a lot of room too.
It does. So let's check out the video that you sent over in advance, an introduction for our audience and our listeners on what we're going to be talking about and what Wabtec does. Great.
The world may look very different in 30 years. As climate change accelerates and the global population continues to grow. The decisions we make today have the potential to shape our future for the better. A better future begins by asking the right questions. By 2050, freight and transit activity is expected to double. Which transport solutions will help protect the environment while safely and efficiently moving large numbers of people and goods? Rail provides the best answer. It is one of the safest forms of transportation. It is cleaner at moving freight and people, and less expensive than any other mode of transport at moving goods over land. Rail investment is climbing. pressure to lower carbon emissions will only increase in the coming years. The good news is, Wabtec is already taking on these challenges with innovative technologies that boost train efficiency, reduce carbon emissions, and decarbonize the transportation sector. Our commitment: safer, smarter, and greener. We've created the world's first battery electric locomotive. We've found ways to breathe new life into aging locomotives to make them cleaner and more powerful. We're paving the way toward autonomous train operations with our digital electronics platforms. We've innovated advanced natural refrigerants for HVAC systems to slash the global warming potential of air conditioning systems. And we've designed new friction materials to radically reduce braking dust emission and pollution. As the world continues to change, we're anticipating future needs and developing smart solutions to the challenges of today and tomorrow. The world is shifting to green, and so are we. We're in the right place at the right moment. Wabtec, moving and improving the world.
What an amazing and fascinating video, Philip. And as we spend our time together watching that video, I saw, if I'm a student watching, so many potential careers and so much potential opportunity. But let's dive into your presentation, and we can dive into some of those conversations as we're going.
Okay, great. Well, let me give a quick overview of Wabtec. If you go to the next page, Gene. Wabtec is actually a very old company. Second page. Yeah. So basically, these are our founders. Names that you've probably heard: Thomas Edison, George Westinghouse, and Louis Faiveley. These are pioneers in creating products which have real world applications. So Thomas Edison created General Electric. George Westinghouse invented the air brake. The air brake system was basically invented to create a safer product. At the time, hundreds of years ago, trains were actually braked by carmen. People would run car to car and actually try to brake the trains. Command. So coming up with a system, a pneumatic system that would allow the trains to brake, was a breakthrough at the time, and it is still used today in trains. Of course, new generations of technologies. But the name Wabtec comes from Westinghouse air brake technology. So that's the origin of the name. So our pioneers here are our founders. If you move to the next page. So who are we? We're headquartered in Pittsburgh, 27,000 employees, operating in 50 countries, about $8 billion of revenue, and a Fortune 500 company.
Philip, can I ask how many of those 50 countries you've lived in? Traveled to?
Traveled to probably 50 of those. I don't know. I've traveled to about 50 countries so far, but I don't know if it's the same 50 countries. I'd have to double check that.
Wow. Students who like to travel, pay attention to that.
Great. Go to the next page, Gene. So, if you look at the business, how the business is cut up, 65% is the freight business. So freight means carrying merchandise, versus 35% is transit, and that's carrying people. Geography, our revenues are mostly coming out outside of the US, but 45% are really generated from inside the US. And an interesting thing, our market, and that's something when we look at companies, 45% is OE. OE stands for original equipment, OEM manufacturer. So creating, designing and manufacturing trains, but brake systems, HVAC systems. So the equipment that are the trains themselves, or they go onto trains. But 55% of the revenues come from aftermarket. That means spare parts sales, maintenance contracts, software sales. So it's important to have a good balance of your revenues in each of these spaces here. Page. All right. So if we dig a little deeper into how we're set up, there are 5 businesses. 4 of them are in the freight segment, and 1 of them is transit. So freight segment, we've got the equipment. So that means the locomotives. You mentioned 20% of the rail is actually moved by a Wabtec locomotive. That's 1 out of 5 locomotives in the world is a Wabtec loco. But then we have the services part, where this is maintenance contracts, spare parts, but also we actually monitor our locomotives using communication systems, where we actually get feedback, a live feedback of how the locomotives are actually operating. We have 3 centers in our world, in different parts of the world, where we do 24-hour monitoring of these locomotives, the faults, the problems they may have. And we treat about 2.5 million messages a day of communication going traffic. So it's quite I would say, a very technologically advanced system that we have. A locomotive is not like the one that you showed earlier, Gene, but it's actually a very high-tech machine that's operating out there. Components, it means turbos, heat exchangers, equipment that go onto locomotives. And finally, digital electronics. This is software solutions that our customers need to operate their trains, operate their logistics. We have an application at Port of LA where we handle logistics for containers coming off from ships and they go onto trucking or onto rail. So that kind of software is like that. And finally, the transit segment, that's really passenger transport. 15% of cars are equipped with our safety critical equipment. For example, brakes can't fail on passenger cars, right? So you can't allow them to fail. You're carrying people, so it's they got to be fail safe.
Philip, I have one question on the second box, the 2.5 million messages per day. What does a message that might be received? Is there a most common message that comes in? Are they 2.5 million unique messages?
Yeah, so of course there are a lot of commonality, but it could be as simple as, hey, everything is good, loco's running well, but in general it's more about, hey, you know what, I'm getting a high pressure in my crank, in my system here or there, or high temperatures. It may be an indication that of a fault that's coming, or therefore you can get some preventive maintenance going to prevent the asset from actually breaking down, or it could actually be, hey, I'm broken down, I need to be fixed. So it's various messages, but it's basically to keep on monitoring the locomotives so that we know and we can prevent actual road failures and to be more productive and more efficient.
That sparked a follow-up question. Are those messages human to human or computer to computer?
Computer to computer. These, yeah, sorry, to make that clear, you're absolutely right. So we have multiple onboard computers on locomotives, and they communicate to the bases, and we have systems that analyze these messages. We also have people who analyze messages. Half of those messages actually have automatic responses. They either trigger a maintenance event, and others are just basically people say, oh, I've never seen this message, or this combination of these 2 messages coming in may mean that we have a problem in this area or another area. So but we try to create more automation in this space so that we can better respond quicker to our customers.
Very interesting.
Okay, go to the next page. So world's transportation has many challenges coming up. It's expected that by 2050 we will have double the freight and passenger activity on this planet. So what does that mean? I mean, it means, of course, more emissions. It means more traffic congestion. Think about putting twice the amount of trucks carrying goods onto our highways, into our cities. What does that make for congestion? What does it make for emissions? So that's a challenge that we need to look at and really understand how we're going to manage that. Of course, coming from the rail business, we say, listen, I mean, rail is a cleaner solution than trucking per ton mile. Just the fact that we have steel wheels running on steel rails, the physics of that make it more efficient than having rubber tires running on asphalt. Just the rolling resistance and the energy needed to actually propel the equipment forward is significant, 4 to 5 times more efficient by rail. So is rail a solution to tackle the growth of freight? Of course, for us, the answer is yes. But do we need to build more highways and we need to widen our highways, or can we use the capacity that we already have on our network? 85% of our network is underutilized in the U.S. So how do you put more onto rail? But of course, if it'd be easy, it would be done, right? There are challenges that we need to tackle. How do we help our customers bring more of this traffic onto rail? Is one of those key questions that we tackle and we work on every day. And for the purposes of making it cleaner, safer, and more efficient.
Mm-hmm.
The next page. Okay, so sustainability is one of those big subjects that we have, and because rail is by itself a more sustainable solution. But the question is, does everybody really understand that and know that? And so we try to drive that message. And one of the things that we've done last year is came out with our first sustainability report. And this report basically helped us to guide or give guidance to our investors and to general population as to where we think where our investments and our energies are being focused. In products, making products which are more sustainable, and that's one of the main elements. But also, how do we utilize resources, our own resources, to manufacture the goods in a more sustainable fashion that use less energy, create less waste, and also how we create a more diverse and inclusive culture is part of into our company, is part also as of our sustainability principle. So we've released this report on our website, and it's accessible to all to consult. And we set ourselves some goals. By 2030, we want to achieve certain goals into sustainable products, waste, energy usage, and things like that.
Very interesting.
Okay, we can move to the next page. All right. So one of these sustainable products is our what we call the flex drive locomotive or flex drive system. So we've been working in the last few years on a very innovative product. In fact, it's the first of its kind in the world. It is a fully battery-powered locomotive. It's a program that we worked on with one of our largest customers, BNSF, and the California Air Research Board into creating this product, which is basically, like I say, 100% battery-powered. It was actually shipped on December 14th of last year, and is currently being operated in a demo system in California between Barstow and Stockton. Its objective is to save fuel, of course, and the version that we have currently running is demonstrating up to 10% of fuel savings. And why is that important? On the slide there, you have the amount of fuel that's actually being spent by the freight industry per year. $7 billion of diesel fuel is being spent each year. Okay, so think about it. If you get 10% of savings, what does that mean? These are big numbers we're talking about. So this is a big deal. And as an engineer who's worked on trying to find solutions to save 0.5% here or 1% there on our engines, when you talk about 10%, it's a big deal for us. So we're really excited about this product, and we're already working on the next generation of locomotive, which will be operating at in the upwards of 6 megawatt-hour of power.
Philip, is that the engine that's on the slide? Is that the demo engine out in California at the moment?
It is. Yes, it's that's correct. And It's exactly the one, unless this is a nice rendering of it, but it's the product looks like that pretty much, yes.
Very cool. And 10% of 7 billion is a giant number.
It is. Okay, we can move on to, all right. So, and I'll end with this slide here. Additive manufacturing. I mean, this is something where we truly believe in, because additive is a new technology, right? And but at the same time, it's a technology where we see a lot of potential and developing differentiated products. The power of additive manufacturing, it gives us the ability to create products completely differently. We are not constrained by traditional solutions such as castings or machining. We can invent solutions which basically go beyond traditional manufacturing processes. We've invested heavily in this case metal additive manufacturing, where you actually print metal parts. We have machines in Grove City right now, and we are currently installing a new machine down in Pittsburgh at this point in time, which will be printing aluminum material. So we're quite excited about it, but it's one of those technologies that you really need to understand and see how it can benefit the products that you generate. And in some cases, it could be lightweighting some products, because if you lightweight some products because of more efficient design, well, you use less energy. Is one of those things that we're striving to achieve with this.
It has been difficult for me not to interrupt, Philip. I love this topic on both fronts. Energy, the climate, the sustainability is a very big deal. Than just being a lover of all things trains. I wrote down, and correct me if I'm wrong in this, as you were talking, if I'm a student listening and saying, boy, this is so interesting, possible careers, just technology, engineering, manufacturing, machine works. And those are just four I wrote down. I imagine sales, marketing, there's a lot of ways.
Almost everything, including real estate, if you want to go there. I mean, for on the engineering side or on the technology side, all aspects or many aspects, I would say, of technology are there. So we're talking about mechanical engineering, electrical engineering, software engineering. You can't imagine how much software we have built in on these assets. Door systems, HVAC systems, all are running on software. So AI is another one that we're experimenting with. How do we utilize these new technologies to analyze to better make better use of our data? But then if you veer away from the engineering side and computer science side, but of course you've got everything has to do with operations, manufacturing. And finance, you think about $8 billion worth of revenues. You need very strong finance folks. So look, tons of career choices that can lead to this. So, but it's nice to be working with people from all kinds of areas in this, and it makes for a very diverse and how can I say interesting work.
We had some questions come in from students who were preparing and learning about Wabtec in advance of our conversation today. Would you be all right, Philip, if I started to dive into some of those questions?
Sure.
The first, I'm interested in this question, is the technology used in automated trains the same as the technology used in the autonomous cars that we read so much about?
Yeah, so I really like that question, because the short answer is no, but there's always saying but . So it's not. So first of all, let's take a step back. So automated trains have been existing for a while. In fact, there's one running at the Pittsburgh airport. The people mover that goes from the terminals is an automated train, right? So automated trains have been around for quite a while now. But they are mostly in what we call dedicated corridors where you know exactly where you're going from A to B, and transit application, passenger applications is the common use of automated trains. So that's been around for a while, but it's using a technology, a very different technology than autonomous cars, because think about it, you got tracks, you're going there. You don't have to worry about what's on the left and what's on the right. So, but you have to make it safe. You have to make sure that you don't crash into other trains and things like that. So, so that technology exists since quite a while. The autonomous car technology relies on is very different. It's more about situational awareness, and then using systems like lidars, which gives you an idea of what's going on, because you know, I call it a 3D problem, right? Whereas trains is a 1D problem, one-dimensional problem, and cars is a 3D problem. So you have to understand where you are in autonomous cars. You still have to do it with trains, but you're more constrained onto your tracks, and making sure you have enough stopping distance between yourself and the next train ahead. In fact, just to give you a bit of an idea why, another reason why autonomous car technology doesn't work or in the case of trains, it's long trains. A long train will take, let's say, a 200-car train, which is being pulled by 2 locomotives, and it's running at 60 miles per hour. It's going to require 1.5 miles to stop. The moment you say, "Oh, I need to stop,"
Yep.
1.5 miles. Now think about it. You know, you can have curves. You can, you know, if you have an obstacle that's 1.5 miles or a mile ahead of you, you might not even see it. And even if you stop now, you will not have enough time to stop and prevent yourself from hitting that obstacle. So that's why you need to have a different technology, but that's for long trains. So, but why I like the question is because, well, what happens if you have shorter trains? Well, then now you're having a different perspective. Maybe shorter trains where you start looking at different technologies that you can utilize. And so those are the things that we're thinking about. But what I really like about that question is more about how the person who asked the question is the thinking behind as to, you know, can I utilize a technology that comes from another industry? So when, you know, as an investor, now I'm talking to you like a normal investor, one of the things that you want to do is understand how the technology that's being developed in a certain company can be accelerated or decelerated by a technology that comes from a different industry. So here we're talking automotive. Automotive, big volumes, millions of cars a year, right? Trains, 500, 1,000 trains a year. That's, you know, volumes are very, very different. Can the train industry drive the technology for automated vehicles, batteries, hydrogen, you know, whatever technology that you're thinking about? Will that industry be able to drive the growth or the development and the cost effectiveness of it in the industry that you're talking about? Or is there another industry in parallel that's doing similar type of technology development that will be able to be applied into this technology that you're looking at in this company? So that's why we're looking at it this way, say, hey, who is going to help us? Which other parallel industry is going to help us develop our technology that we need? Because we're a small industry. We're not a very big industry, and we don't have the might, for example, of an automotive or an aerospace company or industry to drive development. So that's one of the things that we constantly look at, is what will be the driving force behind developing our technologies, which comes from a parallel industry.
That's a great, for a teacher in the classroom, what a great or kind of fun assignment. Compare the parallels between, you know, auto, air, and rail. What can we learn from each?
Truck, heavy machinery, farming, you know, multiple various industries develop technologies. They may not look the same, but the underlying technology may be the same. And
you're implying learning, which is obviously very applicable to the classroom.
That's right.
Philip, does Wabtec design the automated trains?
Well, yes, we have a roadmap to design automated trains. Our objective is really to bring more capacity. I talked to you earlier about, hey, what are we going to do about this 50%, this doubling of transport? So bring more truckloads onto rail is really the question. So for us, yes, we have technologies that we've already started working on and demonstrated with some of our customers. And how do you get more automation onto trains for the purposes of of putting more volume onto rail. So helping our customers, use that untapped capacity that they have in a better fashion. So yes, we are constantly, actively developing that technology.
Our third student submitted question, and I think you alluded to this earlier in the presentation, the conversation. Does Wabtec publish studies if someone wanted to learn more specifically regarding the company's environmental impact?
Yes, and that's it's the sustainability report I talked about. That's our study. In the sense, and I have it here, and I keep it handy because it's my guide to how we want to drive the company in this space. So we've published this report, sustainability report, which gives targets of how to, how much, for example, how to develop products which will bring us more shares of sales into eco-friendly products, or how can we better utilize the materials, or reuse and recycle the materials that we use. So, for example, a target for this is we want to increase by 2030 10% of millions of. Right now, we have about 300 million pounds of use materials that is being recycled. We need by 2030 we need to increase that by 10%. Reduce our greenhouse gas emissions. We produce around 47 metric tons of CO2 per $1 million of net sales. How can we reduce that by 30% by 2030? So we have all these goals that we set ourselves, and for ourselves, and in the company we are driving these goals. These goals actually cascade down to various groups and down to the individual level to say, hey, this is our objective that we set for the company. How are we going to achieve it? What are the actions that we will do to achieve those? And so in terms of, do we produce a report? So this was our original report. This is our telling our investors, hey, this is what we're going to be doing for as objectives by 2030. And on a yearly basis, we update our investors as to how we're doing on these goals. What's our progress regarding these goals? So that's how we tackle that.
That leads well into our next student question, which, and feel free to copy and paste the answer. But how do you measure how does Wabtec measure the reduction in carbon footprint?
So it's varied. So first of all, there are multiple aspects. So if you sell an eco-friendly product, okay, and I'll give you an example for brake systems. One is the product we developed recently is reducing the particles coming out from a brake system. So it's not carbon necessarily, but it's still emissions for us. Okay, so with this product that we developed, how can we get our customers to buy this product, which is more eco-friendly? Or the same thing for a locomotive. How can we continue reducing the amount of fuel that's being used? Because for CO2, it's directly related to fuel. You burn a gallon of diesel, and it's 22 pounds of CO2 that you emit. So the equation, the mathematics are really linear. They're very simple to make. So it's less energy. HVACs, HVAC systems, or heating, ventilation, air conditioning system, which are on passenger trains. They utilize electricity coming from the train. But that electricity has to be generated by somehow. And if the electricity is being generated by fossil fuels, well, if you use less of that electricity, you by definition, or by you automatically reduce the amount of CO2 emissions that you have. So how we measure it, it's by looking at we set ourselves a baseline, and we say, okay, going forward, how do we, from this baseline, how do we reduce the usage or the generation of CO2, both in our products, but also in our operations? We have manufacturing plants. We use water, we use electricity, we pollute by the nature of manufacturing naturally. And so how can you reduce that? And we have teams which that's their focus is to come up with projects which we can bring in and reduce those. And that's another interesting area of career development, is anything has to do with environmental science. Okay, so it's one thing to say I'm going to bring a project, but how do you calculate it, and how do you bring in projects which make sense not only for environment but also make business sense? Because it's one of the things is, we invest, but at the same time we have to make sure that we invest in the right places. So how do you combine the environmental impact with the business impact that you will have, and how do you make this a winning combination? So we have teams who are passionate about that and work day in, day out just to bring these projects and to drive change into our plants to be more environmentally friendly.
That feeds well into our last student question. And maybe I'll add to, if there's a specific example, the question is, what steps has Wabtec taken specific to its products or facility to be safer? Yeah. Is there a single favorite example that you have? And I don't want to narrow it to a single, but maybe we can be more broad.
Okay, safer for the environment. So, I mean, I come from the technical side, right? So I'm going to talk about. I spoke earlier about the battery electric loco. So for us, that's number one. You use less fuel, but the next technologies out there, hydrogen is one of them. Hydrogen is a fuel where today it might be generated using maybe less renewable sources of energy, but as we progress into more solar and wind and hydro and other sources of clean energy that produce hydrogen, then hydrogen does not produce CO2 emissions, right? You basically take water and then you crack it open, and then you convert it to hydrogen, and at the other end you actually consume it and create electricity from that hydrogen into using fuel cells. So the question is, what does that product look like? We heard about hydrogen cars, we heard about hydrogen trucks, but hydrogen trains, there are a few running in the world today, but those are very I would call them light applications, they're passenger applications. But bringing that to the heavy freight industry is one of those challenges that we have. There's a lot of power. A locomotive is 4,500 horsepower. Okay, that's a lot of energy. So how do you bring all that power onto a locomotive? How do you carry 5,000 gallons of fuel? Diesel, a locomotive carries 5,000 gallons of diesel fuel. So what's the equivalent for hydrogen? And how do you carry that? It takes a lot of room, and and this is compressed or liquid in a compressed or liquid form. So it's there's how to bring that technology to the rail market is one of those things that we're trying to make our products better and safer for the environment.
Philip, what does, just kind of hearing the passion in your voice, what does sustainability mean to you personally? We've talked about it at that big context at the corporate level, but I'm speculating by that passion that you might have an opinion on that question.
Yeah, look, I mean, sustainability for me is really what can I do? Okay, so both on a personally at home and how I behave with materials, packaging, recycling, use of electricity and things like that. But as an engineer, I have the ability to do something about it. Okay, and this is where it's interesting. And then as you were watching, showing the video, a thought came through my mind as when I was a younger engineer designing these products, is the pride I had in actually putting something on paper, and then on CAD, and getting the part done and putting it on an asset, and actually riding on. And when I say an asset, I'm talking a train or locomotives, and actually being the engineer that say, hey, I took this product which was so and I brought it to another level. So having the ability to impact with my creativity, my passion for, and my understanding that, hey, I can make a good or bad decision as an engineer. I can make a decision that pollutes more, or I can make a decision that pollutes less, that creates more carbon offset. So as an engineer, I do have that ability, and those decisions really, they come down to us. So that's why for me, sustainability is, hey, I can do something about it. Yes, I cannot solve the entire world's planet's problem, but as an engineer, I come up with these products, and it comes down to me to convince others that this product is better for the planet, it's better for the business, it's better for everyone. So that's what I see about sustainability is, yeah, you can do something about it in your own way.
That is not a small statement you made just before that. What I can do about it for the world, essentially.
Right.
Philip, if a student is watching this saying, boy, I did not know this about Wabtec. This is just fascinating. A final question, what advice would you give to them, or that young person who just is right now saying, I'm going to Wabtec and I'm going to learn everything I can, but they're, pre-college and pre-career. What advice would you share? So
one of the things that when people look at the products we do and the technology we play in and what we achieve, it could be overwhelming. It could seem overwhelming. It's like, oh my God, I could never learn that. Well, there's one thing that I always tell people, you know what? Things are done by human beings. Okay, these things are done by people like you and me. So there's no magic about it. It's about hard work. It's about just digging in, and everybody has a contribution to do. So to bring to the table, and every bit counts. So to me, it's like, you can't learn everything in one day. It took me many years to know what I know. But when I started, I knew nothing, and I was coached and helped by peers. And but in the end, what I realized is once you learn something, it's like, oh yeah, well, actually, it's human scale. It's not. These are all things that you can learn if you put your mind to it. It just needs time and patience. So I would say, my motto is that everything is built that we have here is built by humans. So just dig in and you'll turn around in a couple of years and say, oh yeah, okay, it is doable. Just make sure that you are passionate about. If you have a passion for something, just drive to understand if it's a true passion, and then and see where it leads you. And there's nothing wrong in turning around and say, okay, I'm going to find something else if it's not really my passion. So human scale is the motto I have to explain to young engineers and young careers that it's doable. You just got to learn it and dig into it.
I'll echo that. If you have a passion for something, drive to understand it. I see so many young people that feel that pressure to your point, you can't learn everything in a day.
Nope.
Yeah, eliminate that pressure and have fun.
That's right.
Philip, on behalf of everyone at Troutwood, on behalf of our students and educators, thank you. This was a lot of fun. I personally very much enjoyed this.
Great. Thanks for having me.
Everyone tuning in, thank you for watching Troutwood Live. Until next time.